Hello, everyone, and welcome to our What's New in SAP HANA Cloud webinar. It's actually the second time in this year that we're happy to give you insights into our latest innovations in SAP HANA Cloud, which we are releasing with our QRC2 release of SAP HANA Cloud. My name is Thomas Hammer, and I'm the lead product manager, and I will be hosting the session today. And I'm super eager to give you a glimpse into our release. But before we start taking a look at the content, it's important to say that this webinar is only covering a fraction of the innovations that we are introducing and some of the highlights that we definitely want to share with you. We will also be publishing additional materials that we give that basically give a better insight into the entire scope of the release, so that you can also dive deeper into the rest of the functionalities and enhancements that we are shipping with the Q2 release. That being said, let's directly jump into the content for today's session. Before we take a look at what we will be covering, I think it's definitely important to introduce briefly our speakers for today's webinar. As you can see, I'm not on my own, so we will have product experts walking us through the individual sections of the presentations to show some of the great innovations in their respective areas of expertise. What are these areas? You might now ask yourself. Well, as you can see, we'll be starting off first with a general update. I will be covering some of the great innovations introduced to SAP HANA Cloud, but then I will be handing over to Saphana talking about the innovations in multimodal data processing. After that, we will have Volker and Schrader on stage talking about the innovations in the HANA deployment infrastructure and in database development, followed by Rob talking about the innovations in our SAP HANA Cloud Data Lake. And then later on, I'll be sharing some further news and topics that you definitely should be aware of before we close it with some time remaining for Q&A. But now, without any further ado, let me directly jump into the first section and into our general update with regards to innovations in SAP HANA Cloud. And first, I'm really happy to share that we're making adjustments to our overall cloud infrastructure for SAP HANA Cloud, specifically to the way how we handle connections and how we limit connections for SAP HANA Cloud. While before, for the SAP HANA database, every customer was equipped with 1,000 connections, being basically the guaranteed and the limited amount of connections for a single database instance. We will now introduce the connection limitation based on the configuration. What that means is that with every single vCPU that is configured for your instance, you will be equipped with 500 connections, reaching up to a maximum of 30,000 connections per instance. And that really gives you the possibility, especially also for larger use cases based on larger HANA database instances, to leverage a higher amount of connections and thereby relax the limitations that have been there before. What's important to state is for, let's say, the smallest instances, we're not touching the limits. So it means it remains 1,000 connections as the smallest database instances are coming with 2 vCPUs. So you don't need to expect any, let's say, degradation of the usage. But you can rest assured that for future growth, you're now equipped with higher connection limitations. And I think that's great, as it gives you more flexibility for your database use cases. Directly jumping over to the next innovation, which also is, let's say, in the area of lifecycle operations. And actually, this is about custom backup retention policies. Now, if you remember, the previous approach of how we were handling backup retention was that there was a defined retention period of 14 days for backups of the HANA database as well as the data lake. And now we're giving you the possibility to configure this backup retention from 1 day up to 7 months, which equals the 215 days, which is mentioned here on the slide. As of now, you can basically configure this backup retention via a user interface, but also via API calls, and adjust it to your needs so that the backups are retained either for a shorter period of time or for a longer one. And this helps you to satisfy your needs for instance, long-term data preservation, or it gives you the possibility to, let's say, lower your spending for data backups, especially if your specific use case isn't requiring that. So from my point of view, a great addition, especially for those looking for more flexibility in how to handle the retention of your data. Going on, another feature in the area of lifecycle operations, specifically now for the SAP HANA database and SAP HANA Cloud, is about fallback snapshots. And here, what we're offering now with the upcoming release is a possibility for you to create specific fallback snapshots that help you for an accelerated rollback of certain versions, for instance, after application upgrades. This functionality will be exposed via command line interface calls or API calls, which allow you to take, delete, or to fall back to these specific snapshots. And it gives you, as said, a possibility to more easily restore to earlier versions of your HANA database instance. Definitely a functionality which gives you more assurance that in case of any failures, there is still a version available which is compatible and you can easily roll back to. And it's very handy based on the API commands. We're working on a user interface for the functionality as well, which will be released soon, but we didn't want to delay the functionality, and therefore there is now the API available for your usage. Just keep in mind, snapshots are available for up to 14 days before they will be automatically deleted. That's important to know. And also, it's only one volume snapshot supported at a time. So it means before you want to create a new one, you have to delete the old one. And if you want to see how this is, can be performed, how you can create these volume snapshots, just take a look at the blogs that we're also providing with the upcoming release. The last lifecycle feature which I would like to introduce before we're moving on into the next section of our presentation of our webinar is the template-based instance copy. And now with the SAP HANA database, you have the possibility to create multiple instances based on single database templates. And that is especially helpful if you, for instance, want to create your quality assurance landscape based on a single template. You want to automate the creation of multiple instances and thereby be much more efficient. Same here, the functionality, first of all, will be released with a command line interface command. So we equip you with the APIs to create the snapshots and to create instances based on the snapshots. But then later on, a user interface will be provided as well. Important to know is that the templates will be stored also on our HANA Cloud data lake infrastructure, specifically in data lake files containers. So basically, we make use of all the storage capabilities we also have in HANA Cloud to archive or to store these templates and make them available for provisioning. And same here, if you want to see more details about how to create these templates, we also have sufficient documentation available to guide you through the process. And that's it now basically from my end, talking about general updates, some really great innovations from my point of view already, but now we have much more ahead with the innovations in multimodal data processing. So handing directly over to Saphana.
So good morning, everyone. So thank you for joining us all today. So today I'll be providing a quick overview of the new spatial functions that are introduced in QRC2 release of SAP HANA Cloud. And also we'll talk a little bit about the new built-in function that we have in grep. So let's begin. The first spatial function we'll explore is the hdmakevalid. So its purpose is to address the issue of invalid geometries that can occur during spatial analysis. So these invalid geometries may have been missing or incorrect properties, so making them literally unsuitable for further analysis. So however, with hdmakevalid function, we can now transform and consider these invalid geometries as valid, thus allowing you to continue with your geometrical properties, not face any issues further. And let's take a closer look at how the syntax of this function is and how it works for different types of geometries. Firstly, for points, we have an option to either collapse or drop the degenerate values to ensure validity. And for polygons, we have an additional parameter that will allow you to choose between different algorithms. The first one is the Boolean algorithm and then the even odd algorithm. Coming to Boolean, which is also known as a non-zero rule, the function takes each outer ring of the polygon here and then creates a union and then subtracts all the inner rings to ensure validity. But on the other hand, the even odd algorithm, which works by drawing a ray of line from a specific point to infinity in any direction, it counts the number of path segments from the given shape that the ray actually crosses. And if this number is odd, then the point is considered inside the polygon. And if it's even, then the point is considered outside. So these two algorithms provide different ways to modify an invalid polygon and also make it valid depending on your specific requirements. Next one. Which is ST as GeoJSON, a multi-column aggregate feature. So already we do have two other functions which are named similar, like ST as GeoJSON and ST as SDJSON. But these two functions allow us to obtain geometry JSON objects in their respective formats. However, it's also important to note that output of these functions lacks attribute values, making it less useful for comprehensive analysis. And in some cases, we may require function that provides a complete JSON document. And that is what these aggregate functions actually do. So first, let's explore the first one, that is as GeoJSON, that is ST as GeoJSON function, which is a multi-column aggregate function that will return a string representing a set of rows in GeoJSON format. So it has two groups of input parameters. The first group is an expression list, which you could see here, then determines the content, that determines actually the contents of the output. And the second group is the list of name parameters that control the presence of JSON members, coordinate precisions, and also allows you for possible formatting of your JSON output. And one notable feature here is the support for bbox attribute, which will display the bounding box member in the output. So this can be helpful for understanding the spatial extent of the data. Additionally, this function allows you to include the null property values that are specific to GeoJSON. And coming to data type support and conversion, one advantage of this function is its compatibility with all data types in HANA. So whether be it decimal, binary, the function, this function will automatically convert them into string representation in the resulting JSON document. Moving on to next, which is pretty similar to the previous aggregate function we saw, but this is ST as SDJSON. So where it will return a string representing set of rows in SDJSON format. So we just have new parameters to consider here. For example, we do have object ID format instead of feature ID name, which we saw previously, and we also have an option to display the M and Z values of your geo coordinates. So rest of the way it works similarly, but we could see them in detail in the demo section. So quickly I'll move on to the next one, the Frechet distance, ST Frechet distance method, which is a very good method used to measure the similarity between the line strings. So it goes beyond just like a simple yes or no answer, and it provides a measure of how similar two line strings actually are. So this method is particularly useful when you're comparing line strings and you're performing clustering based on their similarity. So think of it as a way to determine the dog leash distance. So it represents the minimum length of leash that would be needed to connect a dog that is walking along one trajectory and its owner walking along other trajectory for the entire walk. Both the dog and owner can adjust their speeds, but they cannot backtrack. So that is the concept. And coming to Frechet distance method, it operates on geometries. Like I have mentioned here in the syntax, to use this method, you have to provide the method in a geometry that you want to compare to another geometry. You also have to specify the unit in which you want the distance to be returned. So by utilizing the Frechet distance method, we can compare line strings and gain insights into how similar they are. So this information can be valuable for various applications, including clustering the line strings based on their similarity. So that's a quick one on Frechet distance. And next, I have a quick update on what is now new in our SAP HANA Database Explorer. So consider you have spatial data stored in your tables and you would like to visualize the coordinates on map. It is now possible. All you have to do is just choose the points you would like to visualize and click on View Spatial Data option, and you can see them all now plotted on the map. The benefit here is that you're able to see the properties of the geolocation points in detail. Slowly but steadily, DBX is also upping its game towards providing great spatial analysis and visualization support. So with this exciting feature, I will now move on to the graph section. And I will introduce now you to the Louvain algorithm, a powerful community detection algorithm available now with SAP HANA Cloud in the QRC2 release. So with Louvain, you can uncover hidden communities or clusters within complex networks. So this algorithm uses an iterative process to optimize the modularity of the network, effectively also identifying groups of nodes that are densely connected internally and loosely connected to other groups. So let me explain in simple terms of how this algorithm actually works. You can actually see the steps on the right of my slide. So the first step would be to initialize the graph. So this involves creating a list of nodes and edges and assigning each node to a community, and then calculate the modularity of each community. So here modularity is a measure of how well these nodes are actually connected in the community. So for that sake, we have also introduced some helper functions to calculate the modularity of a node, and then find the best split, which is our third step. This involves finding the pair of communities with the lowest modularity gain if they were to be merged, and then merge the communities. The two communities with the lowest modularity gain are merged and their modularity is recalculated. The fifth step, just keep on repeating the step 3 and 4 until no merges can be made. So we can notice that Louvain algorithm is a recursive algorithm, which means it calls itself repeatedly until it reaches a stopping condition. So the stopping condition here is when you no more find any merges to be made and the modularity of the graph cannot be improved any further. The benefits of Louvain algorithms: first one, it provides valuable insights into structure and organization of networks. It reveals the meaningful communities that may not be apparent at the first glance. Secondly, it enables us to analyze and understand the relationship between nodes, thus leading to more informed decision-making and targeted actions. So the applications of Louvain algorithms is vast. I will give some of the examples, like it finds its utilization in social network analysis, identifying cohesive groups of users or communities in online platforms. It also supports fraud detection, uncovering clusters of suspicious activities within financial transaction networks, in building recommendation systems, and we have more. With that said, let's move on to the demo part. I will start with the demo of the first function that I talked, that is the hdMakeValid function, string which has no dimension added to it, which literally is not a string, it's just a point, but is this valid? And when I check that, it's not. How do I make it valid now? So like I said, for the point, we have two options. We either like collapse the line string or drop the line string. In the first case, I'm going to collapse the line string and convert it into a point. And at this point, it is now valid. And then in the second part, I'm going to like drop the entire line string where the line string is now empty. And it is also made valid at this point. This is why, because you can just skip some of the errors that you might focus when you're doing bulk spatial analysis. You just have to ignore some of these things. Then you can use the drop functionality. Coming to the polygon thing, let's have a look at how an invalid polygon looks. This is how it actually looks. And this is not a valid polygon. It is invalid. So how do we make it valid? So we have two options. That is the first one. I will start with the non-zero algorithm, where this is going to just snip off this extra bit of polygon that went ahead. And in this case, this is a single polygon, which is valid. And in the case of even odd algorithm, this is going to be different. The polygon is now considered, now transformed into a multi-polygon, which you could see here, but the entire polygon still remains intact, but it is just considered as two polygons and it is now valid as well. So they both have differences in their own way. Moving on to ST as GeoJSON and ST as SDJSON. For this purpose, I already have a table created with 5 records, points of interest in the city of Waterloo. And you can see that the fifth record doesn't have a name to itself. We will come to it later. So how does the GeoJSON format look? This is how the GeoJSON looks, and this is how the SDJSON format, the output looks from your table. But they are not very much readable, right? So let's do a little bit of formatting. So I'm going to add some indentation, and this is the GeoJSON, and this is how the SDJSON will work with some formatting. And also we have possibility to make the precisions number to 6, because I have a lot of numbers after my point here, but here I'm trying to just grab 6 points, 6 numbers after my point. And then coming back to the last one where I wanted to point out specific details, like we are able to get the bounding box attribute values. And also you could see that I am planning not to consider the null value that I had in my GeoJSON. So for that sake, you can see that my fifth record here doesn't have its name specified. It just has the reference point. But for others, you do see the names because they were not null. And coming to the SD GeoJSON one, I just wanted to talk about, like, we have the ability to showcase the Z and M values in our output. And next one would be the ST fresh air distance one. To just explain that, I will take example of one of the tables we have that contains a number of trips taken by taxis in the city of Porto. So all of these trips are shown as a form of line strings. And in this case, for ST fresh air distance, I want to cluster the line strings, which are very similar to each other. So let's see how I do that. So this is the code I have written for that. I have kind of like split my table into two parts based on the trip IDs, and I have compared the line strings, I mean the trips, by using the condition that the fresh air distance between these two trip line strings should be less than or equal to 200 meters, and only then I consider them very similar, and then I cluster them all together. So how does that look? So considering the line string, so this is one of the trip line string that a taxi has taken, and it has 21 similar trips that are pretty much same as how it is. So we can see all of them clustered here. So one more. So this is one of the trip taken by another taxi, and it has 12 neighbors to it. I mean 12 numbers of other trips that are similar, and they are all clustered together here. And for all of them, the fresh air distance here is less than or equal to 200 meters, which I have specified. And coming back to the last part, just talking about the DBX tool. So I have a points of interest data here. So you want to visualize the spatial representations on a map. You can either like choose one of the data from your shape column, which is ST geometry type here, or you can choose many and then click on view spatial data, which will put those all points on a map. And you can even click on them and then get into details of each of the attributes very well. So yes, that was all from my side. And I think now I'll hand it over to Volker. Thank you, everyone.
Thanks very much, Saphana. So I'm going to share my screen. Hang on a moment. We are talking about HDI improvements and developer improvements, and in particular, I will show you data manipulation language update now being able to be used in migration table, as well as the alter partition in migration table. And the third one is privileges for partition admin. This is a new privilege which you can use, and I will show a demo there. Shraddha will continue with all the tables, scheduler job, and database ID. So the DML is something which you need when you want to manipulate the content of a column while you're changing your object. So the topic here is schema evolution or table evolution. And when you want to adjust the data type, the string length, you want to split a field into multiple fields, or you want to join multiple fields into one field. That's all a situation where you want to have this. So a migration table is always a thing where you put in version 1 of your evolution. So in my case here, a person. Then we have left that out, the version 2, where you have added also the street and the city, and you rename person name to person last name. And the third version, which is the second file here, is where you also have then the street being enhanced to 200 and the house number is added as well. But now you're coming to a situation where you want to go, where you want to go and want to realize that your street is too long. You are good with 150, so you have to shorten your column, and that's normally not possible. So when you want to do that properly, so you go in a kind of rochade here. So rename street to street 2. You take you add the new street with 150, and then you do an update of the left of street 2 to 150, and then you drop the street 2, and then you end up with a structure which is in this format here. So this allows you to do updates, and for the future we are looking also to have insert statements, and will bring further tests, DML support inside the migration table. Another thing we will bring in, or we are bringing in now, is alter partition. So far we had been only able to have alter partition in the beginning of a table construct. Now we are able to make the design time also having changes during table evolution. So the list of incompatible things, or the list of things we are not supporting right now with migration table, has reduced, and we enabled partition to this. And it looks like this. So you have a version of your employee here, version 1. Then you have some migration stuff with version 2, and then the version 3 brings in the partitioning here. And in our case, we had here a range partition of employee IDs just as a sample. So you can bring in, while your table is already existing inside HDI and HDB migration table, the introduction of repartitioning or partitioning of your tables. And the last one is the partition admin privilege, which you can get from a DB admin or from someone who has the rights to give partition admin privileges. And that allows you to change any table in HANA. That includes also HDI tables. So a typical SAP admin sees the schemas of HDI, but he's not allowed to look inside that. At the security we have about HDI, but now you are able to partition without having extra rights for altering. So here's a little sample, but I will show that live. So I'm going into my Database Explorer here. So someone has to grant a user the partition rights, partition admin rights, privileges, and then if you give it with admin, he can give it to others. So let's look inside our database here. So we look at which tables do have a table size and a record number here. So we are looking for candidates. Oh, it's disconnected. So let's see which tables are candidates here. So customer event is one we want to have. So I have right now partition 1 here, and I changed it immediately to 5. So this is a candidate where I can use the partitioning. I had the partition view here. So let's first look at what it is today. It is you will find here our table has one partition with 150,000, roughly 150,000, and we are now going into this table to partition it. And when we see it now again, we will see it has now 5 partitions inside. But at the same time, you can see here, I'm just trying to select something out of one of these tables in this directory. So I cannot access this because I don't have the rights to do this. So I do have the rights to alter tables, but I do not have the right to look into content. So security is given, and we keep the integrity of our HDI tables. With this, I hand it over to Freda.
Thank you, Volker. Let me go ahead and share my screen. Yeah, So let me continue with the rest of the innovation. So firstly, we will look into the alter table features that is there for the HTB table. So one of the benefits of this feature would be reducing the overall resource consumption in terms of when you do the previous or the conservative approach of how the altering of the table structure took place. That was done in order of copying the table and then inserting the data into it. So that is one of the benefits. And let's look into the example. Here we have a table person with the 3 columns that you see here. That's person ID, first name, and last name. So if you want to add an additional column into your existing table, the conservative approach previously was done by as follows. You do a copy of this existing table and you create a new table and then copy all the contents which was there in your first version into this new table and then drop the first version. The process itself was hassle, so this could be avoided overall by making a few changes in your project. So you can have this particular parameter, as you can see on the screen, the try-fast table migration, which is set to true. You can have this parameter set in your package.json file and deploy your project, and that would show the log, which is shown below here. This is a comparison that's done on the 2 approaches. The first snapshot that you see here is the log data of the first approach where the copy was done, and you can see the time recorded in that particular approach is more comparatively, which is done with the new integration of the parameter. So this could be avoided, and this could be the whole process of copying the data could be avoided with this one. You can get more information on this particular parameter in the SAP help documentation, and the snapshot is shown as follows. The next innovation that I would like to show you is with the scheduler job. As the name says, this is the scheduling of particular procedure to take place at a certain time range and at a certain duration. So this would simplify the deployment. It would be enabling the use of the scheduler in the HTI, and also it will be a complete SQL functionality which is residing in the HTI. So as you can see on the screen here, we have a simple syntax of the scheduler job. We have the details like you give your start time to end time, and you can give the procedure that you want to execute at a certain duration, and you can give a cron expression which will basically tell how often do you want to execute this particular job. So these are some of the samples that you can see here is the examples of some of the cron expression that you can set in your scheduler job syntax. The first one you can see here is the first cron expression you can see here is this particular cron job runs every 12 a.m. every day. And the second expression that you can see here is it runs from Monday to Friday at 5:15 p.m. And the third one you can see is which runs the scheduler every 30 seconds. Now let's look into how you can do that in the Business Application Studio. I have a very simple example here, which consists of a procedure which will basically insert the values in the table. I have a table which has basically 2 parameters, that's message and the timestamp. And I have a scheduler job, which, as I showed you with the syntax, has which has a cron expression of running this particular job for 30 seconds and also executing this procedure. So let's go ahead and deploy this. Yep, so this is completed, and let's have a look into my HTI. And you can see that the scheduler has been executed, and we can also have a look by executing the select statement. You can see that this particular procedure is running. And you can always make sure if a particular procedure is enabled or disabled by having this parameter set. If it is set to true, that means that the scheduler is running every 30 seconds. Now we can see if the insertion has been done successfully in the table as per my project. So you can see that the first row has already been inserted, and this keeps on increasing every 30 seconds. So if I go ahead and refresh after a couple of seconds, I can see a second field which has been inserted in this particular table. So in order to stop this from continuously running for every 30 seconds, I can either do two things. I can either set up a time range from start time to end time, or else I can have this alter script, which will basically disable my just give me a second. Yeah, so this would basically disable my, or else I can just go through with this and have a very performance approach of deploying this again. And this would basically stop my scheduler from running every 30 seconds. So just give it a second. And if we look into this particular select statement, you will not see any scheduler running. So basically, that's all about the scheduler. And just like as a use case, we can explain here what you can see here is there are various things that would carry on with the traditional ETL. In the HDI ETL, you have all in one stop. Basically, I could say that about the scheduler job. Moving on, we have the database ID in the service instance, which basically helps to build multi-tenant SaaS applications, and it also improves the SAP HANA deployment infrastructure container management, and also allows the identification of the SAP HANA Cloud instance. So let's have a look where you can find this database ID in your BTP cockpit. So this is my BTP cockpit, and I have a couple of instances here, and I have my shared keys, which is available here. If I look into the form and if I look into this particular field, you can already identify the database ID. So you can use this database ID while you can configure this particular ID in your MTA YAML file, and also you can have a clear identification if you are using a multi-tenant applications. So in case of two shared keys, you can see that it will be identical, and you can also have a look here. And we can confirm that. So right now, we, in order for us to identify, let's consider the C47 in the end, and let's look into the other key, which would basically be the same. So this is where we can make use of database ID and deploy your project with it. In this, I conclude my presentation and hand it over to Rob. Thank you.
Thank you, Shraddha. All right, morning folks, and welcome. So for the data lake, I got a couple features we wanted to talk about today. First off is we have introduced support for transactional DDL. So historically, DDL statements, things like create table, alter table, create procedure, etc., always execute with automatic commits. So each individual statement is committed individually. There was no support for chaining statements, multiple DDL statements together in a single transaction. What we've introduced today, and this is a feature that the HANA database already had, but for the relational engine, we've now introduced support for transactional DDL, where we are now able to execute a group of DDL statements as a single transaction, and then either commit or roll them back as a single group. Now, a couple points here to note is number one, with the relational engine, all HANA Cloud Data Lake relational engine instances are scale-out instances consisting of a coordinator node, and one or more worker nodes. So transactional DDL can only be executed on the coordinator node, and you do need to connect to the coordinator endpoint in order to do that. There are some limitations as to which DDL statements can be supported, and the link to the appropriate documentation page is there for you. So if we look over on the right-hand side here, this screenshot taken from Database Explorer console session shows you the process. In this case, we were working through a HANA connection and sending statements to the data lake through the remote execute DDL command. You can also connect directly to the relational engine using HDL admin or another user and execute transactional DDL directly that way. But often we're working through HANA connections and trying to do all of our SQL through HANA connections. So hence the remote execute DDL lets us pass through that command. First thing we have to do here is set this new option. It's a temporary option, auto commit DDL off. In this particular example, we were making sure we cleaned up any pre-existing tables for our demo. So the transactional DDL table 1 and table 2. And then at this point, we are in a transaction. Automatic commits are off for DDL. So we can create table 1 here, losing my cursor, sorry. We can create a save point, and a save point is a named place we can roll back to if we want to later in the transaction, rather than rolling back an entire transaction. So in this case, we create a table 1, we create a save point named SP1, we then create a second table, and we can do a rollback to SP1. So here we've rolled back the second create table statement, but our first one is there. Insert a record and then commit. Right? If we then, we were kind of cleaning up then, turning the temporary option for auto commit DDL back on, since that is a good default to have. And then if we were to go and execute a remote execute query, what we would see is that we have results available in table 1, but that attempting to query table 2 would show return a table not found error because we didn't actually commit that one. Right, we rolled it back. This is a really, really useful feature when you're doing application upgrades where you have to make multiple changes to your database schema and you really would like the upgrade to succeed or fail as an entire process. And you would prefer not to have to undo each individual transaction, right? So I could, of course, have written individual drop table statements to undo something, but that's a lot of work. So transactional DDL is a really powerful one, and it's actually a foundational requirement for us to start working on implementing HDI modeling support for the data lake. Second feature, a little bit of a housekeeping one, but a really useful one, is both the HANA database and the data lake relational engine support importing data from Parquet format files into either the HANA database or the relational engine. HANA has supported exporting data to Parquet format files for quite a while, if possibly forever. But with the data lake side, we had a gap where we hadn't yet implemented support for unloading data from the data lake to Parquet files. So we've closed that gap, done that housekeeping cleanup with the data lake in the QRC2 release. So now we're able to, we support in our unload statement, the ability to unload to Parquet. That can be either an unload table, so unloading an entire table, which directly maps to HANA. Data Lake also has a really convenient feature where we can do an unload select. HANA, you can do an unload against a view. So you can kind of simulate this by creating a view and doing an unload from a view, which would then look like a table to HANA. But in the data lake, we can actually, run an unload against an arbitrary select. So that's really useful. A couple new parameters for the unload statement that are specific to the Parquet format are the row group size. So how many rows are grouped together? And this is a tuning option when you're unloading large data sets to Parquet. And compression. So the default, as shown here, is snappy. There's about 3 other compression algorithms supported. We have, aligned with the same default compression as HANA would use. And those are the cool new features, the biggest new features for the data lake for this QRC release. And with that, I will hand it back to Thomas.
And we will go on with some further innovations in SAP HANA Cloud. Before I do that, I definitely need to say this to me was an impressive number of innovations already, and I hope you can agree to that. But as I stated in the beginning, you can rest assured that this is not the entire scope of the release, and we're basically just picking out some of the cherries on top of the cake. So definitely make sure to also check out other resources which we're sharing, like our What's New in SAP HANA Cloud blog post or our What's New viewer for SAP HANA Cloud, where we will be talking about the entire release scope. Now, next, I want to give a few additional hints, basically, which areas you should definitely be focusing on and taking a closer look at when it comes to innovations in SAP HANA Cloud. And the first area, which is a super important area for many consumers of SAP HANA Cloud, is graphical view modeling or calculation view modeling, which we use as names interchangeably. So here in this area, without calling out all of these specific innovations that you can see on the screen, there are numerous enhancements which we have introduced and also some great new functionalities that you should definitely dive deeper into. For instance, possibilities to adjust your data previews, to take a look at the, let's say, the application time, period tables, or also for the handling of user-defined functions. A lot of very specific innovations that definitely provide great value for you, and therefore really important to take a look at them from my point of view. As always, we have a very good resource provided by our product expert Jan Zwickel in form of a blog post giving you more details about the innovations and also equipping you with samples and also some sort of walkthrough exercises which help you to better understand the use of these functionalities. So definitely make sure to check that out, and we will be sharing the link with the resources. Moreover, I would like to call out innovations in the area of our SAP HANA clients as well, because especially here we also have some outstanding innovations that have great effect for you on the one hand side from a performance point of view, but also from, let's say, a total cost of ownership of your data platform point of view. Now, the first one is about the network traffic between the HANA client and the HANA backend instances. Means as of QRC2, our Q2 release of SAP HANA Cloud, all the traffic between the HANA client and the SAP HANA Cloud backend is now compressed by default. That means you can save on network data transmission cost, which is great and definitely directly has an impact on your personal bill. So it means the upgrade also resonates or leads to saving with your SAP HANA Cloud instance, and therefore I can really recommend taking a look at the innovation and also consuming the new release. The behavior as such can also be configured, so if for any reasons you want to or you don't want to run with this compression, then you can also adjust it in the configurations for the clients. Next up, I also want to mention the Node.js connection pooling support, because this is also a means for you to more efficiently work with your database instances when handling, let's say, larger numbers of users, for instance, and you want to efficiently make use of these sort of connection pools. Specifically now here for the Node.js version, we have introduced new means, and we give you a tutorial at hand which explains in more detail how you can make use of those connection pools. And last but not least, we have now the support to stream large objects or LOBs with our Go driver, which helps you also to reduce the memory footprint in applications and makes it much more easier to consume these large objects in a more cost-efficient manner. Moving on into a totally different area. So it's now not about the clients, but it's about our front-end tools, specifically about the SAP HANA Cloud Central and our Database Explorer. And I'm glad to announce that now with the Q2 release of SAP HANA Cloud, and actually since a few days already, we have the possibility to give access to a SQL console already in the SAP HANA Cloud Central. For those of you who do not yet have that much experience with SAP HANA Cloud, let me just say a few words about the SAP HANA Cloud Central. Basically, it is our landscape tool and the entry point to SAP HANA Cloud for all our users. And within the HANA Cloud Central, you have the possibility to administrate your database instances, to, for instance, trigger upgrades, to stop your instances, to change configurations, but you also have the possibility to really dive deeper in terms of administration, look at the resource utilization, maintain your users. You can do advanced monitoring of the system to better understand what is going on at your database platform, how the users are consuming the platform, and whether you are in a phase or in a situation where you need to react with, let's say, an administrative task or some correction on your side. So all this is covered by the SAP HANA Cloud Central, and it benefits from previous functionalities provided already by the cockpit and the Database Explorer. And just giving a little bit of an outlook, and as we also introduced with earlier webinars, the SAP HANA Cloud Central is moving more and more into becoming the central tool for SAP HANA Cloud, covering a lot of these activities. One of, let's say, the new functionalities, as I just mentioned now, is a lightweight SQL console, which already gives our administrators and also developers the possibility to run queries right in the tool without jumping into, for instance, the database explorer. Especially handy for, I guess, our database administrators, as for them, they can stay within the HANA Cloud Central and hopefully run a lot of queries already there. We have some great details also about this new capability, which we'll be sharing, as you can see on the screen. It's important to state that this functionality, the SQL console, is only accessible via the so-called runtime independent tooling of SAP HANA Cloud, or we sometimes also call it multi-environment tooling. So if you're surprised that you're not seeing a SQL console within the tooling that you're accessing, then you're very likely still using the Cloud Foundry-based tooling, but we're recommending highly to move over to the multi-environment tooling, as this will provide much more functionality to you already as of today and will be the future path for our SAP HANA Cloud tooling. We're happy to share more details also about the multi-environment tooling so that you know how to access these new great innovations. Still, our other tools, the Database Explorer and also the HANA Cockpit, are still very relevant and very important, as they are super powerful and giving great functionalities to our users. And that's also visible as we're still extending the capabilities. And if you remember the presentation that Shraddha was giving, talking about scheduled jobs, then you can now find a possibility in a Database Explorer also to visualize these scheduled jobs in a more intuitive manner. And you have the possibility to disable them, to delete them, and to adjust them according to your needs. So I think from my point of view, quite handy. And now it's only time for me to say thank you to everyone joining the webinar today. Thank you especially also to our speakers for giving these great deep dives into the highlight innovations for SAP HANA Cloud. I'm super excited to once again announce such great innovations to you, and I'm sure we will have again in a quarter from now a very packed agenda as usual and another set of innovations. Thanks a lot and see you next time.